Hey guys, welcome back to another Vlesson. Today we are going to continue talking about polynomials. So you can take a minute to read the definition of a polynomial function right there. Something I want you to note is we have already talked about polynomial functions in this class. We talked about quadratic functions, which we reviewed last lesson, and we have talked about cubic functions when we talked about parent functions as well. But the degree of a polynomial is something that's important and we'll get deeper into as we move through the unit. It is the highest power in your function. So if you look at problem number 1, the degree in this case is 2 because the highest exponent is 2. This is a quadratic, which we've already talked about. Something that we are just going to review, and we're going to go through some problems and then kind of like solidify, talk a little bit more about end behavior. That's what this whole lesson is about. So quadratics we talked about last lesson. As I look at this on the right side of the graph, my y values are increasing. It is going up. And on the left-hand side of the graph, it is also increasing. Okay, as we look at this next function, we've got y equals negative 1.2 x cubed. If I look at it in standard form, you've got factored and standard form here. My first term right here tells me the degree. So my degree is 3 because that is the highest exponent. My a value is negative 1.2. So as I'm looking at this, I can see that on the right-hand side of my graph, it is going down. And on the left-hand side of my graph, it is going up. So that's something to note. In a third degree function, when the right side goes down, the left side goes up. Okay. Next, let's take a look at problem number 3. Here, if I look at my factored form, okay, that indicates to me all of the roots, right? We talked about that last lesson. X minus 1 gives me a root at positive 1. X plus 2 gives me a root at negative 2. X minus 3 gives me a root at positive 3, and x plus 5 gives me a root at negative 5. Now, looking at my polynomial in standard form, my first term is what I'm going to focus on here. My degree is 4 because that is the highest exponent in this polynomial, which is really easy to see when I'm given my polynomial in standard form. Note, I could also go back and just see, okay, how many x's do I see in factored form? But anyways, looking at the end behavior, notice that my right side is going down and my left side is also going down. Right? Then we're going to move on to problem number 4. And if I look at my first term in standard form, my degree is 5. Right? And as I look at the end behavior, what is happening here? Well, on the right side, it is going up. And on the left side, it is going down, okay? So this is really nice when I have all of the graphs right in front of me. I can just visually see what is happening. What I need to do is I kind of need to make a connection. Well, as I look back at these 4 examples that we just went through, something to note is when my degree is 2 and 4, they both of the sides of the graph, like both the right end behavior and the left end behavior, are going in the same direction. So basically, when my polynomial has a degree that is even, both sides of the graph are either going up or they are both going down. Okay, now that depends on what my a value is. Okay, in this first example, my a value is positive, so both sides are going up. In problem number 3, it's an even degree, so they're both going to be ending the same way. But since my a value is negative 1, which is negative, they're both going down. Okay, so pretty simple when I'm talking about an even function. Next, when I am talking about a polynomial that is an odd degree. So that's examples 2 and 4 in this case. When I have an odd degree, that is going to indicate to me that the left side and the right side of my graph are ending in different directions. sides, okay? So picture a cubic, right? Like one side goes up, the other side goes down. It's kind of like, it's odd, right? They're ending in odd, different directions. So if I focus in on this first example here, I know that my a value, when the function is even, indicates to me either if they're both going up or they're both going down. Well, in an odd function, my a value, in problem number 2, my a value is negative, which would imply that it's going down. The a value will always tell you your right end behavior. So my right end behavior is going down because my a value is negative. And since it is an odd function, they're ending in different ways. So even if I didn't have this graph right in front of me, I would still be able to find the roots of this function, and I would be able to identify the end behavior. It's got roots at a positive 2. It's got a double root at -5. Because my a value is negative, my right side goes down, and then because it's odd, my left side will go the other direction, which is up. All right, looking at the degree of 5, I can notice the same trend, right? I can find all my roots. We already talked about that. Now my a value is positive, which indicates to me my right end behavior. How is the graph ending on the right side? It's going up. And since it's odd, its degree is odd, the left side is going down. All right, so it goes up, down, right? That's odd, whatever. Great. Take a minute, pause the video right now. Look at just this chart that I've got right here. Just kind of reiterates everything that I just said to you. Okay, now that you guys know the rules of end behavior, let's just take a look at some graphs without the polynomials to determine if they're even or odd degreed functions, and then if they're positive or negative a values. So looking at this first example, well, automatically I can note that the right end behavior is going up and the left end behavior is also going up. So when they end the same direction, they are even. And since they are both going up, I know my a value is positive. All right, looking at the next one, I see that the right side is going down, and I see that the left side is going up. Since they are ending in different directions, that's a little odd. It is an odd degreed function. And since the right side of the graph is going down, specifically the right end behavior always indicates to me that what my a value is. Since it's going down, my a value is negative. All right. Pause the video right now. Try the next two on your own. See if you can determine if they're even or odd or positive or negative a values. Okay, check your work. Problem number 7, they're going the same way, so they're even. The right side is going down, so it's negative. Number 8, they're going different ways and behaviors in different directions, so it's odd. And the right side is going up, so it's positive. All right, now let's go through some examples where we are just given the function in standard form first. All right, so looking at my first example here, problem number 9, my degree would have to be 5 because that is my highest exponent. So here we go, degree is 5, which means that since my degree is 5, which, by the way, if you didn't know that, it's odd, that means that they're ending in different directions. And my a value is this 3, that's my leading coefficient, which since it is positive, that means that my right side is going up, which would mean that my left side is going down. Let's look at number 10. Looking here, my highest exponent that I see is 4. That is the degree, and that is even, which means that both ends of the graph are either going to be going up or they're both going to be going down. They are the same direction. And my a value is negative 2/3. Since that is negative, that indicates to me that at the end of the graph on the right side, it is going to be going down, which, because it's even, both sides will be going down. Once again, pause the video right now. See if you can do problem number 11 and problem number 11 on your own. Sorry, numbering mistake there. All right, take a minute to check your work right now. Number 11, the first number 11. It's even, the ends are both going the same direction, and they will both, in fact, be going down because the A value is negative. Next, number 11, it is odd, so they're going in different directions, and my A value is positive, which tells me that the right side is going up, which means that the left side will be going down. Now, 12 and 13, these ones are a little bit more challenging because you are given the polynomial in factored form. So to determine your degree, you need to actually figure out what would be the highest exponent, which you could go through and multiply all of these out, but you can also think about it like this. As I look through this, I can see, well, let's start by finding my A value in this case, actually, because that's really easy. My A value is this -1/2, which is negative, which indicates to me that my right end behavior will be going down because it is negative. My degree is the more challenging thing to find. As I look at this, my first factor is just a single factor, right? It's just x minus 2. My second factor is x minus 4, but it is, x plus 4. It is squared. That indicates to me a double root, okay? So because I have a single root and a double root, that tells me that my degree is 3. So the degree of this polynomial is 3, which is odd, which tells me that my two ends will be going in different directions. All right, let's try this next one. My A value, well, looking out front here, there's nothing written in, which automatically I know it means it's a 1, which is positive. So my ends will be going, or my right end behavior will be going up since that is positive. Now let's count my x's. Here, x, that is a single root at 0. Here, 2x minus 7, that is another single root at 7/2. We had that in our last lesson. And then here we have another single root at -6. If I take 1 plus 1 plus 1, that gives me 3, which indicates that my degree is 3, which is odd. Which means that my two ends are going to be going in different directions. All right, guys, that is all that I have for you for today. Go ahead and try the independent practice on your own. If you have questions, as always, feel free to email me. And have a great day, Nicolay.